Hello and welcome to this lecture. My name is Miracle Chibuzzor Marcel, and I'm the founder and the director of the Pan-African Citizen Science E-Laboratory. So today we are going to be learning about artificial rain and cloud seeding. So at the end of these lessons, you should be able to explain the concept of cloud seeding and describe how cloud seeding works. You should be able to identify the materials used in cloud seeding and also name the different types of cloud seeding methods we use. And finally, you should be able to discuss the limitations and challenges associated with artificial rainmaking. This lecture is sponsored by the FreeAstroScience group. So, as you all know, rain is one of the most important natural processes on Earth because it provides water for drinking. Okay, it provides water for agriculture. Okay, it provides water for vegetation, these greenery scenes. Okay, you probably have this in your country because of rainfall, because without rainfall, you can have that. Okay, this is another one. It provides water for humidity. Okay, it makes everywhere to be moist, and it helps to reduce pollution. It cleans up the atmosphere and reduces pollution. Can even clean up your rooftops, okay, of your house or your building. So rainfall is important. However, rain is not always evenly distributed. Some regions like in North Africa or even Middle East, they do not experience frequent rainfall. There is long period of drought in those places. Okay, while others like Central African regions and some part of West Africa and East Africa here, they experience frequent rainfall. So because of this, humans have always wanted to find a way to control rainfall. So the quest for this started from ancient times. Okay, people tried to use traditional methods to control rainfall. You probably have them in your community or in your village. Okay, so if for instance, if you want to host a burial ceremony and you're gonna have a lot of people, and you know water in rainfall is gonna be a problem. If it rains, you can conduct them. They can redirect the rainfall. They can redirect the rainfall, or if you want rain, they can use traditional means to make it. You probably have heard of such things before. I have them in my own village, okay? So they use traditional ways, and we haven't actually, you know, we haven't actually explored this much, okay? However, it is not reliable, it's not predictable. So scientists came up with a scientific method of weather modification in the mid 20th century. It started with Vincent in 1946. This is Vincent, and these are his team, okay, members of his team. So they discovered that introducing some super cool substances into clouds, they could trigger ice crystal formation. And later on, Bernard identified those specific compounds that promote ice crystal formation in clouds. So these discoveries later became the basis for modern rainfall enhancement programs that we use today. So cloud seeding program works by introducing tiny particles into clouds to influence rainfall. Now, the details of these tiny particles I will mention later. Okay, so but certain kind of particles, not all, they are not just dust. Okay, they're not just dust in the atmosphere. They are just specific kind of substances or compounds that enable uh, that aid rainfall. So Why humans try to control rainfall? Humans try to control rainfall because we want to fight drought. Because in dry regions, long periods without rain can damage crops, it can reduce drinking water supplies, and it can even harm the ecosystem. So, artificial rain can sometimes help increase rainfall during these drought conditions. Controlled rainfall can support agriculture because farmers depend on rainfall for crop production. Therefore, increasing rainfall during critical growing seasons can improve food production. Controlling rainfall can increase water supply because there are countries with limited freshwater resources, which okay, they have limited freshwater resources and can use this cloud seeding method to increase rainfall. Okay, that will fill up their reservoirs, their rivers and groundwater systems. And I've mentioned this before. Rainfall can also control air quality because it can remove dust and pollution particles from the atmosphere, thereby improving air quality in urban environments. So, to understand cloud seeding, we must first of all understand how rain forms naturally through the water cycle. So from this picture, evaporation takes place from water bodies such as sea, rivers, lake, ocean, even the clothes or the food you want to sun dry. So evaporation takes place from the surfaces and they move up as moisture. So when they get up in the upper atmosphere, they 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 lose that heat. The water, the moist air, the moisture. Okay, they lose those heat, and so if they lose it, they're supposed to condense. Okay, but they are that's supposed to be a surface they are to condense. So I'm going to explain that later. So those surfaces helps them to condense. So clouds form, and after cloud formation, they precipitate as rainfall, and water falls back as rain. The process repeats again. So that is the process of water cycle. I hope you'll be able to understand it. I've explained this before in my first lecture. So now to understand this rainmaking method, we need to understand artificial ripening. Artificial ripening. Okay, you probably have seen this before in your village or in your community. If you have a fruit on the tree, and it takes time, it takes months for it to ripen. But if you want it quickly, you can enclose it in a bag, or you can even remove it from the tree and enclose it in a bag. When you do that, you will discover that it's going to ripen. It's going to just take it a few days to ripen. Okay, so by doing that, you are accelerating the ripening process. Okay, so you are just accelerating it. So that is exactly what happens with rain. So if you want to accelerate rainfall, so cloud seeding is simply accelerating rainfall, because if you leave it out, it may take time to rain. But by applying cloud seeding, you are accelerating rainfall. So this is just the same process, the same way we artificially uh, accelerate ripening of fruits. That is the same way we artificially accelerate rainfall. So to do that, you have to first of all, so for rainfall now, I'm talking about rainfall. So now this is how cloud seeding works. So to do that, first of all, you have to identify suitable clouds. Okay, suitable clouds, because not every cloud can produce rainfall. So scientists first look for clouds that, first of all, already contains sufficient moisture and has strong upward currents, and also clouds that has the right temperature and altitude. If these three things are not predetermined before you start pouring the seeds, like if the clouds are too thin or too dry, this process won't work. Okay? So once the suitable cloud is identified, special materials are released into the cloud environment. You can do that using aircraft, small aeroplanes. So you fly them directly into or above the cloud and release those tiny particles into them. So you can see it from this picture. You can use rockets. So you shoot rockets into the clouds. As it enters the cloud or approaches it, it explodes and the particles disperse. You can use some ground-based generators because these machines, look at it here, they release particles into the air from the ground so that wind can carry them upwards into nearby clouds. Can even use drone. I think drone is one of the easiest and the cheapest method out of the whole four. So these are the things you do. So first of all, you identify the suitable cloud. The second, you deliver the seeding materials into the cloud. So now I want to explain what is happening here in the cloud formation process because I've explained this before in my last lecture when I was talking about thunderstorms and lightning. I told you when this moisture, when they get up in the atmosphere, okay, they lose their heat. So there are particles in the atmosphere that provide surfaces for for their condensation. Okay, so places with natural rainfall that experience frequent rainfall, these particles are already in the atmosphere. So this steam, when they come up, they just condense. However, in places where there is drought, they do not have these particles. These particles are not naturally dust. Okay, there are certain particles. I'm going to mention them in the next slide. Okay, so these particles. So in those places where there is drought, frequent drought, and they want to make cause use this cloud seeded method to increase rainfall. So what they do is they introduce these seeding materials, okay, these cloud seeding materials, so to increase these particles because naturally these particles are not in the atmosphere. So they add more. So these processes, this cloud seeding method I just described, those four methods, so they add more materials so to enhance the process, to provide more surfaces for the steam to form. Okay, so this is exactly what happens here. So the more these particles, the faster the cloud formation. So when the clouds are formed, they fall as rain. So the cloud seeding is just to increase the number of these dust particles. Sorry, these particles. Now, these materials used for cloud seeding are one, silver iodide, silver iodide. Number two, sodium chloride. Number three, carbon dioxide or dry ice. And number four, liquid propane. These particles encourage water droplets in the cloud to combine and grow larger. When the droplets become heavy enough, they fall to the ground as rain. So let's go into types of cloud seeding. We have three types of cloud seeding. We have static cloud seeding, which is typically used in cold clouds that contain supercooled water droplets. What are these supercooled water droplets? They are just liquid water particles that remain unfrozen even at temperatures even at temperatures below freezing point. So when you introduce particles such as silver iodide, they trigger the formation of ice crystals. Then we have dynamic cloud seeding. This approach attempts to enhance vertical air movement within the clouds because a very strong upward current allows clouds to grow larger. The cumulonimbus clouds, okay, that is what forms it. The storm clouds, okay, it allows the cloud to remain active for a long period of time and also produce more precipitation. Then we have the hygroscopic seeding, which is mainly used in warm clouds where temperatures are above freezing. Okay, so in this method, tiny salt-based particles are introduced into the cloud, and then these particles attract water molecules and form larger droplets quickly. So as droplets collide and merge, they grow large enough to fall as rain. This technique is usually used in Middle East, UAE. Okay, it's usually used in UAE regions. So a lot of countries use this artificial method. We have China, you have United Arab Emirates, you have United States of America, you have India, you have Australia, you have much more, even Israel. So much more. These are just the major ones. So there are limitations and challenges with this cloud seeding method because this artificial rain does not always work. Okay, so some of the challenges include that cloudbursts already exist in your country. So in your country, if you have frequent dry weather, and you want rain, and you don't have cloud in your atmosphere, you can do it. You cannot do it. Okay, so then the results are also unpredictable, and the technologies used in these cloud seeding programs are expensive, and it's also very difficult to measure the effectiveness. So if you have any question, you can post them in the comment section. I'm going to be responding to them. Thank you so much for paying attention.